Hey guys, welcome back to my channel Shree Sisters. It's been a while, right? And I'm back with a new video on inertia. Will be seeing the law of inertia and the different types in inertia in today's video. So without further ado, let's get into the topic. So first one is what is law of inertia? Inertia is nothing but the inability. Inertia is nothing but the inability of a body to change its state of rest or of uniform motion or direction by itself is called the inertia of the body. It is nothing but the resistance to change. The inability is nothing. It means that the not being able to. The body doesn't change its state of rest or uniform motion or direction by its own self. That is called the inertia of body. That inability is called inertia, resistance of change of state of motion. For example, there's a book lying on the table. If you move it with your hands, you're applying some external force, then only the book will move. It won't be if you say book come here, then it won't come by itself, right? So the inability is this force, the inability of it to come, when I call it, that's only called the inertia. If you move it only, it will come. And the car also, if it's a car is moving, if you apply a brake only, it will stop, right? So this is also a inertia, because we are applying external force called brake, so for it to stop the motion of the car. So this is nothing but inertia. I hope you understood. It's nothing but resistance for it to change. If it's in rest to change to motion, some force should act on it. And if it's in motion and to change to rest, also some force should act on it, right? So I hope you understood what is the basic means of inertia. Let's see what it's given in here. In the absence of the external force, the body which is in the state of rest continues to be at rest, and the body which is in the moving will continue to be in uniform velocity. The body cannot change its state by itself. This property is called as inertia. Due to this property, the body opposes the change of its state. Mass is the measure of inertia. The heavier the body, the greater is the force required to change its state, and hence the greater is the inertia. So if there is no force, you are not putting any external force. If the body which is in rest, it will continue to be at rest. But if it's moving, for example, a ball is at rest, it's in a room or something. If you kick it with an external force only, it will move, or else it won't move. And a body, for example, after you kick the ball will keep on moving until you apply an external force. So this is it will continue to be in the state of motion and rest until an external force applied. And it cannot change by itself. Ball cannot change its own movement by itself, or it cannot, from rest to motion, it cannot change its state by itself. This property is only called as inertia. So what this property does, this property will oppose the change of the state. It will oppose, from rest to motion, it will oppose. It's a force that opposes the change of state of motion or rest. And this is called inertia. How will we measure inertia? This is all fine, but how will we measure it? So how we will measure it is nothing but mass is the measure of inertia. So how much ever mass we are, the heavier the object, the tough it will be to move it or to keep it in rest. If ball means it's light in person. If it's a very big rock or something rolling from the mountain, it will be very tough to stop it, right? Because it's very heavy compared to a small ball. So mass, the heavier the object, the more the inertia will be. So nothing but the opposing force will be. So this is the measure of the inertia. The heavier the weight will be, the heavier the inertia, and heavier the it will resist more to change its motion or rest, right? So this is the measure and what is inertia. Next we'll see the types of inertia. Inertia is of 3 types. We are going to see the different types with example now. First is inertia of rest. We'll see inertia of rest first. So inertia of rest is nothing but nothing but the inability of a body to change its state of rest by itself. So nothing but a body in rest will continue to be in rest until the external force is applied on it. Like when a body is like a book, as we have used this example before, I use it again. A book is on the table. Unless you put your hand and apply some external force, it won't move. Why it won't move? Because the inertia of rest is acting. Because of the inertia of rest. Like because of the inertia of rest, it won't be changing itself from rest to motion. This inability is called as inertia of rest. Let's see some examples. For example, you're moving on a bus. Like now the bus will be at rest. Starting in a bus stop, when you are getting on the bus, it will be at rest. Suddenly, when the bus is moving and you're standing on the bus because there's no space, so suddenly if the bus is moving forward, you will experience a backward jerk. Why is it? Because your lower part of the body, which is your legs will be in contact with the buses, so they'll start moving forward with the bus. But the upper part of the body, because of inertia of rest, it doesn't move like the lower part of the body, and that's why we experience a backward jerk. This jerk is caused by the inertia of rest. And the second example is when you're dusting a carpet, how do you dust it? You dust it with the carpet like a stick. You beat the stick on the carpet and then dust particles will come out. And how does this happen? This also happens due to inertia of rest. How? It's how in the sense when you're beating the carpet with the stick, the carpet will be in the motion, right? But the dust particles will not be in motion. They'll remain in rest itself due to the inertia of rest. But the carpet is moving, so because of the inertia of rest, this dust will automatically fall off the carpet. These are the two examples for inertia of rest. I hope you understood. And now let's move to inertia of motion. Inertia of motion is also the same, but it's inability to change to rest. Like the inability to change its state of uniform motion by itself. From uniform motion to rest, it won't be able to come. I.e., a body in uniform motion cannot accelerate or retard on its own. Like what is this in the sense? Like when a body is moving, to increase speed or to decrease speed or to increase acceleration or to change direction or everything, like a car moving, we need to apply some external force, right? So unless we are moving some external force, the speed won't change or decrease, or the acceleration will not change, or neither increase nor decrease. So the inability to change its state of uniform motion means acceleration equals 0. So the inability to change the state from uniform motion to rest, or to increase acceleration to decrease acceleration, this inability is known as the inertia of motion. Why is it caused? Because of the inertia of motion. So first let's see. The passenger, like in a bus, the passenger, like when the bus is stopping suddenly in a bus stop, what will happen? We will move a bit forward. You all might have experienced this, right? Why it happens? Because the feet in contact will come to stop, but the upper part of the body will continue to stay in rest, so it moves. A sudden forward jerk will come. Because of the inertia of rest, we'll suddenly move a bit forward, like a small jerk will come, and we have already seen. And a person jumping out of a speeding train will fall forward. The next example, like why will that happen? Because his feet will, when we jump from a train, the feet will be in like rest on touching the ground, but the body will continue to move forward. Like the body will continue because of the inertia of motion, it will continue to move forward. That's why the person will fall forward when the person is jumping out of a speeding train. And you don't try this at home or anywhere, guys. So this is the two examples for inertia of motion. And for the third and the last one, inertia of direction. What is inertia of direction? Inertia of direction is the inability of the body to change to the direction of motion by itself. So the direction, like it will be moving in the same direction unless you apply some external force. This is only inertia of direction, like unless compelled by some external force. And as we have seen before, example, you have tried a stone to one end of a string, a thread or string. You have tied one stone and you are circling it like a whirling it, And then if the string breaks suddenly because of the force you applied or something, what will happen to the stone? It will fly tangentially along to the path it's at that point, right? This is because the pull, like because of the break, there was a force acting for the stone to move like that in a circle, but the string breaks and vanishes. Even though the string is breaking, it will move tangentially in the same direction because of the inertia of direction. And next example we are going to see for the inertia of direction is the rotating wheels of a wheel, like of wheels of a vehicle, throw mud tangentially due to directional inertia. How is this? You might not be understand. I will explain. So, like when you are in a car, like for example, a muddy pool is there, and suddenly the car is going and getting stuck. What you observe in the side and corners and all, the vehicle will throw tangentially. It will throw mud, right? You might have observed it, right? So this is because of directional inertia of that wheel. And this is the last of the different types of inertia, and this is it for today, guys. Thank you so much for watching this video. Do like, share and subscribe to Shree Sisters. And for detailed notes on inertia, do check out my Instagram at Shree__sister. Thank you so much for watching, guys. I hope you understood. If you have any doubts, do leave them in the comment box below. Thank you so much for watching. Bye.